Welcome to Module 6, the electrical characteristics of microphones. In the previous sections, we studied the acoustical characteristics. By the end of this module, you should be able to understand the electrical characteristics of microphones. There's 5 electrical characteristics of microphones, real quickly. Sensitivity, equivalent noise rating, overload, impedance, and the signal-to-noise ratio of a microphone. Let's take a look at what these are. Sensitivity first. Sensitivity is the level in millivolts that comes out of a microphone with a specific standard sound pressure level coming into the microphone. So in other words, we're saying how much sound comes out of a microphone given the amount of sound that goes into the microphone. In other words, it's a measure of the efficiency of the microphone. There's a lot of different scales for measuring sensitivity of a microphone. You got your dBm per 10 dynes per square centimeter, your dBm per 10 microbars, your dBV per 10... the important point thing here anyway is you got to use the same scale, or you have to convert from one scale to the other. By types of microphone, ribbons are by far the least sensitive electrically, acoustically. They are the least sensitive microphones. Moving coil microphones have pretty good sensitivity, and capacitor microphones, mainly because of their built-in amplifier, have the best sensitivity. So let's take a look at self-noise, the equivalent noise rating. This is nothing but the noise that comes out of a microphone with no sound going in. This is measured in an anechoic chamber. With self-noise, of course, the smaller the better. If you have a microphone that has an equivalent noise of 20 dB of sound pressure level, you got an excellent mic. What causes self-noise? Well, with a dynamic mic, it's the movement of the electrons in the voice coil, and with a capacitor microphone, it's usually the built-in preamplifier that causes the noise. So we have sensitivity, the equivalent noise rating. Our third characteristic is overload. Overload is simply how loud of a sound can a microphone take before the output becomes distorted. Ribbon mics are the most sensitive. They can be damaged by too great of a sound pressure level, especially if that has a high transient. In capacitor microphones, usually the internal mic preamp overloads before the capsule does. Often you'll find a pad or an attenuator built into a condenser microphone. Okay, sensitivity, equivalent noise rating, overload, impedance. Impedance is the total opposition to current flowing in an electric circuit. Most professional mics are low impedance devices. One of the advantages of low impedances is you can use very long microphone cables without losing a lot of your signal. The electrical characteristics: sensitivity, equivalent noise rating, overload, impedance, and finally, signal-to-noise ratio. This is pretty simple if you stop and think about it. Signal-to-noise ratio is the difference between the maximum sound pressure level that a sound can take, or the overload, and the microphone's self-noise. Well, for example, you have a microphone that can handle 140 decibels before it overloads, and its self-noise is 20 decibels. The signal-to-noise ratio is a simple difference. The sixth electrical characteristic might be considered the proximity effect, but this only happens with directional microphones. It's the increase in the bass response as a result of this mic's directionality. The closer you get to the microphone, the more the bass increases. And this can be an advantage or it can be a disadvantage, so they put a switch in the microphone to roll off those bass frequencies. Okay, quick review. Sensitivity, equivalent noise rating, overload, impedance, signal-to-noise ratio. Now we've seen the electrical properties, but hang on, there's still more to come. Move on to Module 7, using microphones.